more difficult, like learning any programming language, trying to understand too many things and all. So starting is the problem. If you start and if you move towards working on it, automatically it will become a great asset for you. And it's much more easier than learning any programming language. So that's to make the context very easy and most useful to you. So shortly, this is going to be the agenda for 1.5 hours or so. So I think I had the opportunity to listen to a day before 2 days talk. So the first day I have understood that a broader view of what machine learning is and what are the categories that are available. Everything is clearly explained by the professor. And some of the machine learning algorithms also was also taught in the session, like decision tree, and I hope it is some clustering, SVM, so many things that professor. Yesterday, since it was more of an electrical domain, really I could not understand most of the things, but finally it's a MATLAB simulation. So I thought today the entire industry is moving towards Python, and it's becoming more and more easier and popular in the sense of usage, in the sense of availability, in the sense of scalability, and so many other things. So, and I won't work on MATLAB, rather I prefer Python because it's a combination of all those things. Like if you want to use a networking data set, if you want to use mechanical data set, if you want to use any power modeling or anything, okay, so any operating system based commands, okay, and you go to system wise working in the computer science, everything and anything is possible inside a single domain. And yes, once the modeling is done, the UI can also be implemented completely using this same Python module also, and hence we prefer using Python. So this is going to be the context. So machine learning, what does it mean, and what are the packages that one should know whilst before starting to work on a machine learning modeling. And then I had one example data set I have taken, which is an electrical power consumption modeling, which is available in public. Just I have searched for one electrical data set, and I have done one regression modeling on that, and that we will be discussing. So both the third and the fourth agenda is going to be hands-on. So that's my plan. If you want any change in that, you can always stop and tell me. Okay, so what's intelligence, right? So that's the more important question, the why you and me are here. So many graduates are coming out of engineering domain, but it's known that less than 50% is getting placed everywhere. Doesn't mean that the other rest of the 50% doesn't have knowledge, but the intelligence, what the interviewers tell, or it is defined as that there is a difference in intelligence, that is either IQ quotient. Okay, what does it mean? How is it being measured? It's always intelligence which is required in one's own action. Okay, be it a human being, be it a machine, which we do have. Okay, normally earlier at our homes we used to wash clothes by hand. Later on washing machine came in, which was not completely automated, it was semi-automated, right? So it will wash in one drum, and after that you have to lift all the cloths and put it on the dryer machine. But human beings become so lazy in one sense, or very busy in another sense, that they don't want at least this kind of action to happen. So what happened actually is the intelligence was brought in. Okay, so intelligent machines were made to reduce either the work done by the human, or to reduce or to improvise the quality in the work that is done by the human, on both the cases, right? So the quantum of work done by the human resource needs to be reduced so that the human resource can be used efficiently. That is on one pace. The other pace is, as you have lot of activities to be done on a daily basis, so we need to improvise the quality. Okay, so that quality will always gets compromised. Let's say by God's grace, I don't have any problem in delivering the lecture today, but what if I had some personal issues, right? So that's where we have people try to broaden intelligence on the machines. So the intelligence that was originally there with only the human being was slightly moved out to the machines, and that's where we expect and we rely more on the machines rather than the human beings today. We never, let's say, if I want to know about the weather condition of today, what about the storm, whether it was over or is it going to happen, how many hours it will rain, okay, so I don't want to ask my husband, or I don't want to listen to my father or mother, okay. So who actually have gone, might have looked into the sky and inform me. Rather, I rely only on the information given by Google. I rely only on the information given by the weatherman on Facebook. Okay. So all our alignment and our mindset itself got changed to rely mostly upon your what to say, the machines rather than the human beings. Okay. And the same has been applied in the electrical domain also. Now, all the grids are termed only as smart grids rather than normal grid. Power grid, the word itself has gone out. It's all only smart grids. Okay. So the main thing what I have understood, I don't have very great knowledge on that, but generally while speaking with some of my friends working in electrical domain and all, it is like, see, we have done one project on load balancing. Okay, automatically the load has to be distributed across the grids, okay, based on the necessity. At night we have a company that is running nearby, okay, and we have a petrol bunk that is running nearby, and we have residential apartments here. So what happens now, depending on the requirement for a particular, see, all are residing at the same place, so the company may require more power at night, and the residential areas may require more power during the morning. Okay, so depending on that, if you have an intelligent system to switch back, okay, the distribution without the necessity of manpower, that adds value to the development or in evolution in the next electrical engineering domain. That's how this intelligence is also required in every domain in electrical domain too. Okay, so just quickly, I have a I hope people can unmute and talk. Yes, ma'am. Can the audience unmute and talk, or is it restricted? Hello.
Hello, ma'am.
Yes, ma'am. Yeah. Audience can unmute, right, ma'am?
Yeah. We'll inform, ma'am. All the participants.
Okay. No. Just so, how does this diagram look like? Can any of you, can one of you tell me how does what do you infer from this diagram? Just a small question, not related to machine learning.
Participants, you can unmute yourself and you can interact with speaker. Participants, you can unmute yourself and you can interact with speaker.
Ma'am is like a teacher teaching the students and she's asking what is it and students are
Thank you, very good. So actually it's looked like a teacher teaching the context to the group of students. Okay, it's actually a very basic traditional classroom environment where the teacher, normally before this pandemic, this is how we were all, okay, and this is a traditional classroom environment, and some context teacher is trying to make the students to understand. Okay, so what this teacher will do as part of this teaching learning process, right, what this teacher will do, so they'll try to understand the listening skill of these students. Okay, when a student is not listening on a particular time, okay, but if she will be, by since eye to eye contact is there, the teacher is able to understand that the listening skill is not that much good on a particular date. If that happens continuously, then we came to know that there is a problem with the student. And what are the interest areas? Somebody might be good at theory, somebody may be good at practical sessions, somebody may be good in doing their own projects. Okay, it depends from human to human. So what are the interest areas of the student community, that also the teacher can able to understand, and what is their understanding level, right? So since the, see, looking at a person, you can very easily able to understand whether they are able to understand the context of your teaching or not. Now it's difficult, it's not possible because we could not able to see each other, and the question answering also becomes a problem. So that understanding level is always there. And what style of learning this? Because here she has drawn one diagram and it's a visual learning, right? You can demonstrate something and you can make. Somebody likes to have videos, somebody likes to have audio, somebody likes only textbook, somebody likes multiple choice question. Okay, there are different styles of learning that exist among the student community: visual, auditory, kinesthetic. So many are there given by the research community. Everything is possible to be understood by this teacher when they are able to meet this particular person. So what is happening? It's an experience that this teacher is gaining over this corresponding students. Okay, but what is expected? Okay, all these things are happening, it's fine, but what is expected out of this teaching learning process? So initially, when the performance is assessed by means of a test or an assessment, the student might be in a level. Okay, but I want the student to achieve the success. Any teacher wants their student to achieve their greater success, that is to reach this position. So when the student is only at this understanding level, what will the teacher do? They will think, what is the reason that may be the problem creation for this corresponding student, or what might be the reason that becomes the base for the deviation of a requirement. They will plan and they will act accordingly. Okay, so if he is more interested towards visual learning, the teacher may able to give a lot of videos for him to understand. If he is not able to understand, he can or she can teach again and she can come out. Anything the teacher can do, and after some time he will reach the next position. And the process will get continue. The final motivation is to make the student to reach the target. Okay, so which is the success that comes out of this thing. So this is actually the teaching learning process that is happening. Okay, so what in short is happening? You have the list of understanding, okay, about the corresponding student, and you have methodologies to react. See, these are the understanding about the student. So in order to improvise these understanding, you have lot many methods. Okay, I have a method of counseling. I may go for counsel the student. I may I may talk to their parents, I may talk to him personally. So many different modeling are there. It differs from one student to another student, or differs from one teacher to another teacher. But finally, what is expected is to have a graph like this. So the performance needs to get improved, okay, on a longer scale, and we reach or we expect the highest performance always. Now, so this is what we were talking about. Okay, so always if you look at there is a requirement for a performance improvement. It's not the fact that always you can reach the greatest point at the starting point itself. You can be in any point in the middle, and after some time you can, just a minute. Yeah, after when you are in this point, you can move by changing your parameter and the learning style. Finally, at one point of time, you will achieve this success, right? So how is it happening? Okay, there are a lot of parameters behind that. That's what we have discussed here. But finally, what you achieve is your success, right? Now, mapping this to machine learning model. Okay, so what is actually happening? The context what we have discussed is teacher centric. Okay, so teacher is the main important concept there, and this teacher will be given with lot of inputs. Okay, the inputs are coming from the students. Okay, and the teacher will change different strategy. Okay, different strategies to bring the student to a particular level. This learning could be mapped properly to a machine learning model. How? Let us see. Okay, so what's happening is actually the task. Okay, what is the task given to a teacher to make their students to achieve success? So 100% success is my requirement. Okay, how does this can be achieved? By understanding the position of this particular candidate and by giving lot many strategies. Okay, so I may plan to reach the person to a greater height. Sometimes it's not always be on the positive side. When he is in a particular position, when it is overstressed, he may come down. Again, we have to make the move. So everything is may be possible, but these are all the activities that we do continuously to make the student to reach the success. How does this parameter gets measured? Okay, so how do you know that he has achieved 100%? Normally we go for conducting test. Okay, that is on the classroom environment. Same if you map to machine learning. Okay, so here students are learning Now we want the machines to learn. That's it. That's the only difference. So what is expected here? A task is important. Okay. You need to have experience. So what is an experience? Every time, what are you going to learn? Okay. So based on different sense, it is not the teacher cannot understand completely about one particular student. It's all the whole learning classroom experience that makes a perfect teacher. Okay. So you'll have set of experiences. With these experience, you will try to do a task, and finally you will be measured based on some test, which is nothing but the metrics or performance. Okay, so that's what I have pointed out here. You will have a list of experience. What is that? Experience is what we'll be trying to gather on a day-to-day basis. Okay, every day we'll try to gather a lot of experiences by our day-to-day activities. With the set of experiences, we'll try to do a task. Okay, what is the task here? It is to make the student to achieve success. This task may be anything. So both are important. You need to have experiences and you need to have a task listed out. So these tasks, once it is performed, it will be measured on the performance metrics. Okay, here the metric is test. Here the metrics, when somebody is running on a running race, the metric would be the number of seconds he took to reach the destination, or the distance that is between the first player and him. Okay, anything could be taken as a performance metrics, that depends. So this is what is the teaching process or the learning process that happens in the classroom. This is what is the learning process that is happening in the machine. So what needs to be understood here is, in both the cases, you are in need of a task, you are in need of set of experiences, and you are in need of the performance. If this is clearly understood, that's all. Part of machine learning is done. So any domain, if you take, be it your electrical domain or mechanical or anything, for first interest should be to make out the task or the collection of experiences. Both are possible, right? Sometimes we might have the chance to collect a lot of data from different sources. Once it is done, you can look out the data, you can analyze and find out what could be inferred from that. Okay, because let's say you have Facebook, you have Twitter, social media sites. Okay, they are not targeting towards any particular task. Rather, it's just a repository of, so be it a good information or a bad information, nothing wrong about it. It's a collection of information they are collecting, and that collected information is digged for analysis of data, information from it. Okay, that data is being collected and that is stored somewhere. So once this data is analyzed, some sort of information we can get to know from that. That is one way. So you collect experiences because that might be the easiest way for you. Once the data gets collected, organize and do some analysis, find out whichever information you are able to retrieve from there. The other way around, okay, you have a task. Let's say if Apple has come out, okay, forget about Apple. So we'll go for Indian made LG phone has come out with the next product. Okay, so if the next product has come on in the market, if that particular mobile company wants to identify how about the feedback of their product. Okay, so the task is defined here. The context is to understand the feedback about the product, newly released product from the public. Okay, so you initiate how to collect the waste means collect your experiences. So what are the experiences you want to collect? That you initiate, come out and create a data set, and that's how you can go for modeling also. So it is on both the cases. Either you can start with task, go on collect your experiences, or you can start with experiences, go on identifying a task. So coming to the slight difference between what traditional programming will do and what machine learning will do for us. In traditional programming, we know there exists a computer, okay, for which we will be trying to give a program and a data as input, okay, and it will try to give us an output. So for example, I have given one sample input here. So this is a simple program to print sum of two numbers. Okay. This is a simple program to print sum of two numbers, and this is the input I am going to give to this program. So what this computer will do, it will always try to map this input, it will always try to use this input to process this particular program, and the output will be given, okay, back to the user. So that is what the traditional programming will do. So this computer is dumb here. Okay, it is not intelligent to do any extra analysis on your data. Rather, it is trying to just work on the program. It uses this data to work on this corresponding program, and it gives you the output. Okay, so this computer, normally we say it is a dumb system. Okay, so this program is what the developer will write, and this input is what the developer will do. Just it will get executed over here, and the output will be given back. Now, in contrast to that, what is happening in the machine learning? It's completely different now. You will have a computer to which you'll be giving the input data and the output as the input to the system. Okay, the data. So what is the data? It is nothing but your input. This input and the output you'll be trying to give to the system, and this computer will try to give a program as the output. Okay, so see here, the developer is not giving any program. So the computer is intelligent enough to produce a program as the output. Okay, again, a computer, you may ask, it's an electronic machine. How is it becoming intelligent? This intelligence was brought in again by the software developer community. Okay, so it's that the end user doesn't want to write the program. Rather, it's a software that is already making the computer intelligent, is trying to come out with the program. Okay, now, for example, I am giving this set of inputs. 5 and 6 are my input. This is input 1. This is input 2. 5 and 6 are there, and the output is 11. 2 and 3 are my inputs. 5 is my output. 3 and 6 are my input. 9 is my output. Okay. So the system has to understand what is the pattern that exists between these inputs and output. Okay. So, and it will try to come out with one program that may correspond to this input and output mapping. Okay. For example, in all our aptitude tests will be given with a series of this kind. For example, 1, 4, 9, 16, and it goes on. Okay, and you may be asked to find out what is the next number in the series. So how does our mind will think? We'll try to find out what is the relation between these things. Okay, sometimes it may be like 1, 2, 4. Okay, and then 7 and so on. So what would be the output? What would be the next number here? Yes, can any of you tell me?
11, ma'am.
11, how?
There's a difference of 1, 2, 3, and then 4.
Yes, for good. So that's how our mind gets to identify the different patterns that are available. The pattern may be different, but this pattern identification is the only task that our human mind is doing. Okay, the same way when you give the input and the output, okay, and a sequence of inputs and the outputs, automatically this computer, which is intelligent enough through the algorithms that you are giving, tries to come out with one such output. Actually, the output will not be like so. It will be in the form of some equations. For understanding, I have given. So it will give a program as output, to which if you give the next number, let's say if I give 11 as my next number, and if I ask what is the next number in the series, automatically it will give me 12, 13, 14, 15, 16 as my next number. Okay, so that is the difference between machine learning and traditional programming. I hope the context is clear in this. Okay, now, so we have just seen an introduction in order to map that, okay, and to understand the different components we do have on the machine learning model. So this is actually learning. Learning is the task that we do have at our hands. You will be given with a lot of materials. Okay, the material may be of text or anything. And what's expected is to understand your learner style. Okay, and once the materials are given and you understand the styles of the learner, and the exam will be conducted and your results will be analyzed. Okay, so let's say if I have got only 96% in my examination, and if I want to improvise, okay, I have to find out what are the improvement strategies. So in what way I could improvise my result. And that this is, it is not only on my side. Okay, so this is on the student side to identify the improvement strategy. The teacher has to understand what are the innovations that you can bring in to improvise your result also. Finally, how will you reduce your failure rate? See, 96% you can improvise to make 100%, or else you can reduce that 4% to bring down to 2% to improve your success rate also. Both are good. So it's the same if you map it to machine learning. So the inputs are given by experiences. Okay, the features are identified by the data scientist. So what are the feature? Let's say if I'm talking about the power grid. Okay, so what's the voltage? What is the at a particular time, that could be taken as one feature. What is the voltage rating on a particular point? Okay, what is the power that is consumed? What is the power that is generated? All these are the features. Okay, that needs to be identified by a data scientist. So once it is done, so if you give your input, which is nothing but the experiences for the characters that you have identified, that is the features that you have identified. Okay, you can run a machine learning modeling and you can check the performance metrics. Okay, what is a performance metrics? It is many, like depending on the type of algorithm you use, it may be your accuracy, or it may be F1 score, or so many other things. Okay, so I know that this much is the accuracy level I got. If I am not achieving that particular rate, okay, my algorithm is not giving me this much result. Okay, what can I do? I'll just go for adjusting some parameters called hyperparameter. What is that differences? See, the inputs you cannot really change, because that is what you are collecting from the original field. Okay, so you are collecting data from the original field that you cannot change. But whatever data you are trying to add or remove, let's say here in this example, okay, suppose this data you cannot change because this is given by somebody. Okay, only thing is, when your answer is not relevant, suppose 11 is not there in your output, what will happen? You can change the policy that you have made in order to arrive at the result, but you cannot really change. So this policy is what we call as the hyperparameter. Okay, so this is more important in machine learning. So hyperparameters are the values that we may make, or that the machine tries to give it by itself. Okay, it's an assumed number which the machine uses to come out as an answer. So that you can change and you can try to bring in an improvement on your performance. So if not, okay, so let's say I have changed so many things, I have done, what happens? See, I'm working too much on a student, but he is not able to improvise. Then I have to go for changing the teacher, or I have to go for changing the methodology completely. That's what is model analysis. Check whether the model can suit, otherwise go for using another model. That's what is that. And then final thing is regularization. What is regularization? As I already told you, if 96% is the result percentage, okay, so where we can analyze on what aspect is why those failures have happened, okay, and what is the criticality on those failures. What if the 4% gets lost? See, it is now, if it is not a real critical operation, you may have a 96% accuracy, that's fine. You take a COVID case. Okay, suppose a patient is actually COVID positive, but your machine learning algorithm has predicted negative. On the other side, if a person is actually COVID negative, but it has predicted positive, so which needs to be given more weightage? The first thing is what we call as type 1 error. Second thing is what we call as type 2 error. So type 2 error is acceptable. If your machine learning algorithm is detecting positive, fine, he is going for a 14 days quarantine, that's all, nothing is going to bother. But on the other side, if he is positive and if he is detected negative, it's very critical, right? So there is a lot of controversies that may exist there, and hence it needs to be given more importance. That's what we call it as regularization technique. So it is working on the failure part of the analysis. Okay, I hope the context is clear. And when to use machine learning, this is more important. It's not the fact that always we can go for using machine learning. If your task cannot be done by a human expertise, okay, you have a very large volume of data, and if you think usage of human potential, it will waste the human resource, okay, or if it is really a task in which so many polynomial operations functions are there, and if it really cannot be understandable by the human being, you can go for using machine learning. Suppose if it consumes exhaustive human expertise and a task that cannot be explained by human, this is more important, right? You are analyzing the data sometimes if the complications go more, okay? So if it is sinusoidal, okay, to a linear equation you can use, to two-level polynomial we can think of, but more than that, if the polynomial goes on between the relationship, then it will be very difficult, and hence you should not use. If the task needs to be adaptive to different entities, okay, let's say you're opening Flipkart or Amazon, it is not looking like the same for all the users, right? So it may look for different, even though if I open from the same laptop, it may appear different for you and for me, which is not possible by a human being, okay? So that's the case when you want the task to be adaptive to different entities, and tasks that are based on very large data, it is very important, right? Clustering, most people say that it is just grouping. Yes, of course it's grouping, but on what basis you need to group, that is the question mark, okay? If you have only one feature, fine, you can segregate depending on that particular feature. But if you have n number of features that is growing large, so it is very difficult for the human being to understand the basis on which the grouping has to be done. So it is basic grouping, but since the complexities grow more on a very large data set, it needs to be like so. Okay, quickly, I'll in another 5 minutes, I'll close this slide because this is already known to you. Okay, so you have lots of data. Okay, so if you ask somebody about the generation of data, even if I talk now, it is also generation of data. If you are listening now, it's also generation of data. Okay, so everywhere you have data. So, but what is the potential in having this data? Is it important to store the data? Yes, it is important because we have to identify ways and means of storing this also. Okay, you may have data of this kind, you may have data of this kind. Okay, this you can store in a table format or in a image format or something. This is a textual data which won't, like if you have something from Facebook or any social media, the data won't be structured. Okay, it will be in an unstructured format. For example, the mobile review, I like the display is okay, but the sound is not good. Is whether it needs to be considered to be a positive command or a negative command, no one knows. Okay, so that's the question. So there are always two different viewpoints in understanding this ML modeling. So one is the data engineering aspect, wherein we have to understand on how to store the data. Okay, most of the electrical application, I hope it is only numerical data, so no problem at all. The second aspect is data analyst. Okay, so when this data is given to you, what are you going to do with that? Okay, if the data as such is available, it is not enough, so it needs to be converted into information. So how are you going to convert this data into the information becomes a question mark. If you identify this pattern, that's all. You can add business value either to you or to your student or to anybody else. Mostly the data will look like this. Okay, so when any person comes to your home, even for taking the census, so you could have seen one data sheet that will be available at his hand of this format. Everywhere when you want to store the data about a group of person, this is the format. Okay, here if you say these are called the features, feature 1, feature 2, feature 3 and feature 4. I have 4 features, and these rows are what we call as experiences. Okay, so time seconds. Okay, so in which second am I going to take the data? Solar irradiance, this is a solar data set. So what is the ambient temperature and what is the electric demand at that particular point of time. Okay, so this is one simple data set. If you take, these are the features. So this is what you have to understand. So for a particular domain, whatever data or whatever characteristic that could feature the domain becomes its feature set, or the attributes or the characteristics. And you can have data between individual unit. Okay, let's say at 0th second, this is my data. At 60th second, 128th second, likewise. Okay, it goes on for around 25,000 rows. Okay, so and this gets stored. And these are what we call as the experiences or the data set. Okay. And in machine learning, it should be completely understood that one entity is always independent of another entity. You cannot have relationship between these two. Okay. If you feel like it is a time series data and you want to understand, you have to move on for time series modeling like LSTM or recurrent neural network. Machine learning algorithms assume the fact that always one experience is independent of another experience. Okay, and this is how you always your data set will look like. And coming to the madam has already discussed about it. You can have anything like number, string, or date, or anything, time, if you want to have anything, Boolean operation. So whichever format you want, you can have. Finally, coming to inputs and outputs. Okay, so can any of you tell me what are the inputs in this data set? You are looking at 4 different columns, right? What would be the input of this data set? What would be the output? Or whether there is no distinction between these two? Yes, anybody please? How does this look like? Is it all considered to be inputs, or is there any specific segregation on inputs and outputs? Am I audible?
Irradiance and the temperature is the input, ma'am.
Yes, yes, please.
Solar irradiance and the temperature is the input.
Solar irradiance and temperature is the input. And what about the output?
Electric demand must be the output.
Electric demand might be the output. And what about time seconds?
I think that is also an input, I think.
Yeah. And is there any chance of having this electric demand also not to be an output?
And yes, from electric demand is an output.
Yeah. Okay. So thank you, sir. One thing is, if you look at, okay, so as the given and as per the given answer, if you see, solar irradiance and ambient temperature could be taken as the input, for which you need to have electric demand as the output. Time seconds, if you look at, actually, if you look at the answer, okay, there is a slight dilemma of whether to have this as your input or not. Okay, in which case we normally say this is an index. You can add it as an index, or you can have it as an input, or when you are more concerned about the second in which this particular activity happened. Let's say the solar irradiance might be very high, okay, on peak mid of the day. Okay, let's say at 1 p.m. or 12 p.m. Okay, so the irradiance may be very high. So if that is the case, this time seconds also play a matter, in which case it also needs to be taken as an input. In other case, let's say I don't know whether this electric demand is an input or not. Okay, what you can understood is all these things are just data. I don't have any input or output for me. So that is also, because otherwise you assume this is not an electrical demand, rather it is labeled as some value. Okay, for which we don't know whether it is an output or not. So accordingly, you have 3 categories of data sets you could see. Basically, it is 2. So I'm just telling, one is supervised, another one is unsupervised. Supervised, if you look at, you will have list of input variables and then designated output variable. You can have 1 output variable, 2 output variable, 3 output variable, or any number. So anyway, supervised means you'll have list of input variable and an output variable. On the other hand, if it is unsupervised, all the data will look like the same. Okay, you cannot have really distinguish on whether it is a output or an, case all the data needs to be treated uniquely, and you have to just go for grouping the data, grouping of these entities. Okay, which of these experiences can be put together on the same group? Okay, and what could be on the second group? That's what is the only possible operation. Coming to supervised, most of the electrical data set is supervised. Okay, then in supervised, you have two categories. One is regression, second one is classification. How comes this difference? Again, it is very simple. Look at the output column. It is all numbers, not only numbers, when it is falling on a particular range. Range, if I say, let's say if 0 to 1 is my range, okay, so I may have values like 0.1, I may have like 0.12, 0.0012, anything, any value that is within the range is possible here. That we call it as infinitely finite. Okay, so it is within the range, so anyway it will be finite, but you don't have restriction on what value you can have. In that case, we go for regression algorithm. Classification is if you have only restricted value. Let's say I have values like 0, 0.5 and 1. Only 3 values are possible. Okay, so I may call this as A, B or C. Okay, so that is what is classification. Doesn't want to have only the categorical values like strings. You can also have numbers, but numbers also indicate a label. That's what is about in general about your data set. Okay, so accordingly you have supervised learning algorithm wherein you have regression, classification. Some of the algorithms that you have already seen is linear regression. Linear regression is for regression. Decision trees and naive are for classification. And you have support vector machine. But if you see, all the algorithms will really calculate only a number at the end. Okay, let us say all the students are evaluated on the exam. Okay, earlier we used to give only the mark. 93, 92, 84, 85, 50. Only the numbers will be given to the student. That is regression. But what happens now? This marks has to be mapped down to the grades. But what is actually evaluated by a teacher is only the mark. That's how every algorithm will only end up with a number. If you give that number itself as an output to the end user, that is what we call it as regression. Okay. Or else if you are going to map it to a corresponding range, and when you label it, we call it as classification. 90 to 91 to 100, label him as S grade. 81 to 90, label him as A grade. That's what we call it as classification. And you have unsupervised, which is just a clustering algorithm. You have lot many clustering algorithms available. It's very limited. So, and you have ensemble. Okay, ensemble are like improvising. See, Sachin Tendulkar's ad, boost is the secret of my energy. Okay, so when do you need boost? Boost we won't take. You don't need to take all the time. Okay, when after your lunch you don't need to take boost. When is it required? It's only when you feel like you are in loss of energy. So you are running a model, you feel like there is some loss of accuracy and the model goes failing for a particular reason, you go for ensemble. So why is it happening? Mostly if you go for a very long trip, okay, so continuous running. So when the data set is very large, and if the algorithm, see, you need in the electrical case, you will have repeaters, you will have adapters, not adapter, I hope, it will be repeaters, I hope, okay, to boost the energy. When I don't have a particular signal point near to my home, what my cable operator will do, he'll try to give a repeat, boost the signal. Sorry if I'm wrong technically. So if it will boost the signal and it will try to reach the next person. That's what is ensemble running. Okay, it will work on the basic algorithms, but it will try to give boost to the existing algorithm. Why or when to use this? When the data set or the number of characteristic or the features grows more. You have random forest. Random forest, as the name implies, it's collection of trees. So decision tree. Okay. Break down the data set into small data sets. Calculate decision tree or create decision tree for individual data set. Combine together, that becomes your random forest. Add a boost algorithm. Okay. Any algorithm you run, but only for the nodes which is not producing proper output, you boost it. Okay. So XG boost. So all these things are what we call it as ensemble learning algorithm. Okay. So, and this is in short about your modeling process. Every real world entity is generating your data. You cannot use the data as such. Okay. As such, it will be in a text format. As such, it will be in a data format. So many different formats you may store. It may be with some appended characters. Okay, some value may be missing, and some may in a different range. Some device may be malfunctioning, which may give a different function. So all that you need to pre-process, and there is one specific subject called exploratory data analysis, which talks only about this pre-processing. It's more important, okay, rather than collecting data. How are you making the data ready for machine learning modeling is all about the pre-processing. So once done, you have to search for the features, unwanted feature. Let us say if my interest is to find out, okay, what would be the result percentage of a first year student after he gets into your college. So what happens, I may have a record of how much he scored in 10th or 12th, but 12th marks will have a greater impact than the 10th mark. But his name or the state from where he come from, his father name, mother name, may not have an impact on the output. So, but the data set will have all those things. So dropping out all those unwanted things and combining or giving weightage to whichever is important is the next step. So if you have unwanted features, yes, you go for dimensionality reduction, or else if you feel like all the features are important, then you move ahead, train the system using your train the data model using the data set. Finally, training alone, we cannot stop. You always needs to check whether it is really of any program. If we write, automatically will test. Okay, without testing, it won't go out. So you have to test, and finally you have to analyze the result. Okay, so that result analyzing is very important. It goes on different dimensions, and that's where the research community can have an interest over that. Okay, analyze the result. It's not always, see, nowadays easily you can secure 99% accuracy or 98% accuracy on any data set. What about the research that can happen? It's not the fact. Why that 1% failure is happening? What makes it to happen? Is it the same for the entire model? Or when you're going to add too many data back to the data set on a later date, will the same model work with the same efficiency? That's what we need to analyze at the end. Okay, so where can you add this machine learning? In the electrical domain, you have smart grid applications, you have power generation, wherein you can say that this much is the expected power on this particular period. Okay, so that this is one area where you can predict. Actually, smart grid, you have hundreds of applications. You have voltage stability. I have seen some applications which people are using. So in order to give a stabilized voltage, you can get to know periodically on how much is the consumption on a particular, let's say I have told you an example, right? We have a petrol bank, we have a residential apartment, we have a temple, when we have a company running at the same place. Okay, and each of these will be using the power in a different pace or a different timing. So in order to have a stabilized distribution without affecting any distribution or the usage, you can go for using this smart grid application. So voltage stability is what one professor is working, that I could see. So coming to the different Python packages that you need to learn before implementing this machine learning algorithm. Actually, it is very easy to move ahead with Python. Okay, so Python is an interpreted environment which is ready to use actually. So some prior packages might be of use for you. One is numerical Python, NumPy. Okay, so you would have used math package in other languages. MATLAB is greatly powerful only because of this stabilized mathematical operations. The same is provided here using two packages, NumPy and Pandas. Pandas, what is Pandas is? It's a powerful data frame creator. Data frame is nothing but a matrix. You assume that it is. So all data sets will finally end up with only rows and columns. So we need some set of operations to do directly on that matrix. Okay, so that is where Pandas lies in. So it will take the entire data set as one object, one matrix, one object, find out or do all the operations. That's where Pandas is. So the more important thing on machine learning is about the visualization. Okay, so you do hundreds of operations. It's not a matter of interest to the client or to the business person, right? What is their expectation is to have a proper visualization both on the data as well as on your output. look at the business presentations that people do. Okay, we are not bothering about what is happening inside. Okay, they'll try to come out with a visualized document. So that's where Python supports various visualization package, the basic being your PyPlot and Seaborn library. And coming to the machine learning, so there is a library called SQL at scikit-learn, where the machine learning modeling is readily available, which you can use. See, actually, it gives both the flexibility of using it as a package, and also you have the flexibility to change the hyperparameters also. Hyperparameter means, suppose if I want to go for 100 iteration, okay, yes, you can do. If you start with 10 iteration, yes, you can do. That flexibility is also there. Okay, so I'll move on for the screen. Just tell me whether this is visible. Is it visible? My Jupyter notebook is visible.
Yes.
Visible, right?
Yes, ma'am.
Yeah. So this is actually a Jupyter notebook environment, which we normally use for modeling machine learning application. So basically, Jupyter notebook is very smart enough to hold both your data as well as the comment. Okay. So normally in programming language, we used to write comments in order for the other third person to have a look at. So this is a combined environment where you can have blocks of code written along with the comment. Okay, so you could see here, this is actually I have written as a string, NumPy, numerical Python. I have fixed on image. Okay, and I have written a code inside. Okay, these are all the code blocks. These are all the text blocks. Okay, so this code blocks you can execute, and one more important thing is you don't need to execute everything in sequence. You can skip out whichever you don't want. Let's say if I want to execute this, I don't want this, I have to directly go here. Yes, you can do. So that is the most flexible environment that Jupyter Notebook gives you. How to install this is like, suppose if you have installed Python already, core Python, okay, then you have to install NumPy using the command pip install. But every package as and when you need, you can go on adding it using the pip install command followed by this command name. But there is one wrapper called Anaconda. This Anaconda, if you install, automatically it comes out with integrated all packages installed together. So that's what I have installed today. And when you install Anaconda, this Jupyter Notebook is part of it. You can just open it. It will open on a browser window. Otherwise, if you don't want to use this, okay, so and if you say that you don't have Python on your screen, yes, you have another provision given by Google, which is Google Colab. Okay, Google Colab is a Google collaboratory cloud-based environment, which gives the same environment as that of the Jupyter Notebook. Okay, you can see here, this is the examples that are provided by Google Colab itself. Okay, and if you have stored your data onto your drive, I have so many files over here, I can open it. If you have an integrated GitHub account, automatically you can load or store there, or else if you have the files there, you can upload it from here. Okay, and suppose if I want to create a new notebook, yes, I can create. The only requirement for that this is to have an internet along with a Gmail account. Okay, automatically this environment, it is very similar to, yeah, you can see here, this is again a Jupyter Notebook. Okay, so if I print hello, and if I execute, it will execute and give the output for you. So if you have a very large data set, if you feel like your system cannot support, directly you can go here. You can see that along with run type, if you go hardware accelerator, along with CPU, Google gives GPU also at free of cost, and tensor processing unit also at free of cost. So if you have a very large data set which your system doesn't support, you can go here. So this is a flexible environment as such. If you don't have the system to use with, you can definitely use. So as usual, how you use hash include statement, here it is like import. The package name is NumPy, as NP. This is an alias we create for the package. So all the time in using NumPy would be of disturbance to me, and hence I'm going to rename it as NP. It will create a copy of it and it will take. So I'll just go through quickly. So this is how you can create one-dimensional and two-dimensional arrays. Okay, so in a line you can create, and all the data about your arrays can be understood using this data type. Okay, and then what is the actual data type of each and every element? What is the shape? Okay, in which it could be. What is the size? Size refers to total number of elements you have. Okay, you have 12 elements. That is what item size means. What is the look, that is size of each and every element. Okay, if it is integer, it take 4 bytes. That's what is 4 bytes. Total storage, if you want, you can use n bytes. Okay, and this is more easy. Look at this. These are the advantage. Okay, you can create 0 arrays, 1 array, identity array, random array within the range. Okay, all that within the single command. Okay, you don't need to get input and create it automatically. Like MATLAB, you have this provision. And you can create array within a range using this command, array range. Okay, so this it gives start element, end element, and the step value. So here in Python, always the end element will not be taken other than li in space. If you start with 1 and it is excluding the last element, so it stops with 9. Okay, so what is the step value? It is 2. So suppose if I change it to 3, you could see the values. Sorry, I haven't executed NumPy. It will take a minute. Yes, done. So I'm skipping all these things. I'm executing only this part. Comma. Yes. So you can see here 1, 4, and 7. So that is the step value. So the other way is you can use li in space, meaning that I'm specifying only the start and the end value. Within that, how many different values I need to have. Between 1 and 10, I want 50 elements. So I don't need to bother about the step value. That is done here. And this is more useful over this. So once created with this, different slicing operation are possible. Slicing is trying to get the data from here at your ease. Let's say I want to get only 0 and first row. Okay, yes, you can have like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 you can have. You can get only the columns indexed with 1 and 2. Yes, these two you can have. Suppose if I want to have data like 7, 9, 12, 14, that is also possible. Any kind of slicing you can do from here. So that's what I have given here. Okay, so strides I have created. You could see here 2, 3, 12, 13. 2, 3, 12, 13. You can skip any row, you can skip any column. That's the biggest advantage. And you can go for creating masks. Okay, masks is a very important concept in most of the image processing algorithm. Okay, you need to hide some, not only image processing. See, suppose if you want to hide some portion of data and if you want to show that for processing, you can go for using mask. So, and all the operations like calculating some product, minimum, maximum, all statistical operations are permitted here. Okay, and the arrays you could do arithmetic operation, trigonometric, logarithmic operations are possible, vector operations are possible. So you name any operation on the array, it is available at ease on your Python programming language. So that's what is about. And coming to pandas, what pandas is all about is, I have already told, it is just a method to invoke your matrix. Okay, so you are storing your data in terms of rows and columns. If you want to load it and if you want to do any operation over it, we go for using pandas. Okay, so this data frame, you can assume it to be a matrix. So what I did here is, I'm going to create one matrix of this kind. You can see here ID of the student, English mark, max mark, and science mark. Okay, what I have in my hand is, I have the list of student. English teacher gave English mark, max teacher gave max mark, and science teacher gave science mark. what I did is I have created a data frame for myself. So data frame, you can see it is in the rows and columns, that's all. So this is by your creation. If you want to create your own data set during the runtime, yes, there is a provision that means this. What if I had already stored data onto my Excel and if I want to load it onto the system? That's what is the import statement will do. So there is an option called read CSV. If you have CSV file, it is read CSV. If you have Excel file, it is read Excel. You can directly download from URL, read URL. Okay, so you have a data set in a particular place. Every time I want to use it. Okay, and this is the location where I have stored my data set. Okay, so the first 5 rows, if you want to check, you can use head. Last 5 rows tail. Okay, and shape will tell you what is the number of rows and columns you have for this. You could see here, this is the data set. Okay, suppose I'm doing some operations on the data set. I'm going to change, add the age by 1 since it is a new year. Everything I'm changing. I want to store it back. You can see it is a very simple 2 CSV or 2 Excel. That's all. It will get stored it back. Since it looks like a relational database. Yes, it is a relational database, right? Since it looks like a relational database, all the SQL operation, query operation that we do there, like selecting a particular set of column, inserting a data, deleting a column, changing the value, everything is possible over here. Okay, so that's this. And you can create index. Okay, so if you don't have an index for your data set, suppose if you want to create, you can create. So that is possible. And what is the type of data you have over there? Okay, what is the shape of data frame? What are the columns you do have? Okay, so what are the columns? Heading, what are the attributes you do have? That is got by df2.columns. Okay, and you have the rename operation. Suppose if it is too lengthy, skin thickness, I don't want to type everywhere, I want to change it to ST. Just in a line you can change. This in place is equal to true tells the fact that the modification needs to be done and it has to be updated on the same file. It is like a is equal to a plus 1. Do addition of 1 over the value stored in a and store it back to a. That's the meaning of in place is equal to 2. Then if you describe your data, it will tell you how many number of count is there. Here if you see 768 data are there available on all the columns. It won't be like so. Some values may be missing, in which case it may reduce. This is a complete data set. And here, what is the mean for each and every column? Okay, what is the standard deviation? What will be the minimum value, maximum value? This is the median between first value, that is the first value and the 25% of the value. Similarly, what is the center value between the first value and the 50% and 75%? So that's where, see, this predictions are very important when you want to understand, okay, how the data will look like, or how the data gets skewed, on what range it gets skewed. Okay, likewise. And you have slicing, like how you did for numerical Python. It is you can also group here. Since you can do any aggregate operation, count, sum, finding mean, sum, median, everything you can do using group by operation, group on a particular thing. Okay, and moving on to the visualization package. I'll just move on. These are all line plots. See, in a line you can have lot of plots. You name, you can have that plot. This is also a line plot. This is also a line plot of sinusoidal type. 2 line plots merged together. Okay, and you can have scatter plots. Difference is when you connect these 2 points, it becomes a line plot. When you just plot it, it becomes the plot. And this is also a scatter plot, but the points are fixed one near to other. So the advantage here is the twin axis plot. When you have one common x attribute, and when you want to visualize it on 2 different attributes, okay, that you can have. See, x between x and x squared, between x and x cube. Okay, so if you want to visualize, that is there available. You can have different styles of markers and colors that are available for you. Okay, and bar charts. Okay, so bar charts are for quantitative representation. So when you want to say how much runs people have scored on a particular year on a particular data, you can use it. Okay. And this is also bar chart for a very large set of data. This is for smaller data. Here the x-axis grows more. Okay. And this is also bar chart for different. See, here it is for single data. Here it is for multiple data. And you have pie charts. See, you look at this is a long time back when the COVID was most in America. I drew this. So when you want to move it aside, and if you want to show it separately, you can do this. This is exploding. I have exploded the largest area and I have shown. Okay, and that is there. And this is by using pie chart. Okay, I have drawn this using pie chart. One over the other I have drawn. And this is histogram. Okay, histograms are for qualitative representation. So both may look like the same, but there exists a difference. This is for qualitative, that is for quantitative representation. And it's a 3D plotting, like in MATLAB, we have 3D plotting also. It's very easier to visualize. See, if you visualize the original data and the predicted data side by side, automatically you can see how data gets distributed. Okay, here this is one biggest advantage, subplots. Okay, so when you want to visualize the data distribution between multiple grids that are available in a particular screen. Okay, so that is possible in a very easier manner. Okay, so you can have vertical charts, you can have horizontal charts. So an improvised library which is available with us is Seaborn. You could see here. I'll just show the difference alone. This is one important graph which machine learning enthusiasts should actually use. This is a heat map. Okay, heat map is just a visualization map running between the maximum value to the minimum value. Minimum value will be represented in black color, maximum value with white color. And if it is red distribution, between this black and white, you will have red distribution. Here, if you look at this, we could see that the data is more skewed towards the minimum value of the entire range. The minimum value is 0. Since more black part is there, you can observe that the data is more skewed, okay, towards the lower minimum. Okay, it's not normalized value. That's what is the observation we can make from this. This is very important observation that we need to do while proceeding. This is box plot. Okay, this is more useful when actually you have to pre-process your data. This box plot, if you visualize, this is the minimum value. Okay, so if you see here, this is the maximum value, and this is in 25% range. This is in 75% range. Okay, anyway, between minimum and maximum, it's fine. What about these points? Or these are the outliers. Okay, suppose you have a sensor fitted with your machine electrical component and you are trying to get data from the daily, it is recording the data. So if it goes wrong, okay, how do we come to know? That's where these outliers are called. Okay, for example, in your department, if everyone is getting salary around 50,000, okay, suddenly if a guy enters and if he has given a salary of 1 lakh or 2 lakh, okay, this we call it as outliers generally. They may be of interest, but actually among the distribution of data, we may not take them into account. That's what we mean by outlier, which is most important to understand that the data may not be proper on a particular area. So normally the system will discard this. Okay, so the outliers will be discarded before processing the data. So in Seaborn, for pre-processing, heat map is used to understand the correlation, and this box plot is used to understand the outliers. So with this, I'll move on for one data set exploration. So this is the household power consumption data set. I'll just a minute, I'll open and show you. RQ. This I have downloaded from Kaggle. Okay, there are two main repositories that are available for data set downloading. One is UCI repository, another one is Kaggle, Kaggle. Okay, so if you search for data sets, you can get public data set. Other than that, I have seen some other data sets exclusively for electrical also. If you see here, the entire it is available as a text file, not as CSV or any Excel. It is available as a text file. The data get separated by semicolon. Okay, you can see here. So the values get separated by semicolon. Okay, so and it is a floating point value. You have date and time, okay, initially, and you have global active power, reactive power, voltage, some other parameters are there. Okay, I have used this data set. It's a very large data set, lot of values are there. Okay, so what I did here is, these are the packages we have imported. These are all what we have discussed: NumPy, Pandas, PyPlot, Cplot. And for pre-processing, I'm going for normalization, and hence you have used min-max and standard scalar. Shortly I'll tell. And for calculating the metrics, we have used mean squared error and R2 square. These are the metrics for regression analysis. Okay, what I did is, yeah, so I'm going to create a data frame using the pandas. Okay, but since it is available as a text file, we need to convert that into an Excel, CSV or an Excel file. So this is the source from which I took the data set. Okay, the separator, what is the separator that is there? It is semicolon. Okay, the data are segregated by semicolon. And what if you there exists no values on a particular, see, it's a known fact that you won't have values all the time. Sometimes it may be empty also. Okay, let us see whether any empty values are there. Here you see here in these tools. Is this visible? Is my notepad visible?
Yes, madam.
Yes, ma'am.
Yeah.
Yes, ma'am.
Thank
Yes,
you.
ma'am.
You could see here the datas are not here, right? So it's all given as question mark. So there may be space or there may be question mark depending on your value. So what we did is, because this question mark, we are converting it into not a number. Actually, not a number is a special data type supported in Python. So sometimes 0 may represent one value. One may represent another value, but how to represent that I don't want. Let's say in a COVID case, where if a patient is asked whether you have a diabetes or not, if they have, we have to mark it as 1. If they don't have, if we have to mark it as 0. What if a patient doesn't know that whether they have a diabetes or not? You cannot really go for 0 or 1, and you cannot introduce 2 also, because that has an impact. So in that case, it will be left empty. That emptiness is given by not a number value. Okay, so and we need to parse the dates. Okay, so DT column, we need to have both date and time together. Okay, so here in your notebook or notepad, if you see, this date is there, this time is there separately, but we want to combine both the dates and we have to put in as a single DT column. Okay, that is up to you how you define. So, and the column which I'm going to use it as index is this DT. After creating this date and time, we have to use this DT column. So once it is created, the entire data set will be loaded in the format or like this. Okay, so what we did, just a separator is semicolon is what we have used. And if I want to print the first 5 rows, you can use head. If I want to use only the 2 rows, yes, you can do. It will show you only the first 2 rows. It's taking a minute, just wait. The data set is large. Yeah, let it come. So, and in order to find out how many rows and columns are there, shape value. You can see here, see, yes, it has come. It is 2 only, 2 rows will get. So it is around something like 20,75,259 columns are there. The data set is huge, and 7 attributes, 1, 2, 3, 4, 5, 6, and then 7. Okay, so I want to get the information of what is the data type so that I can proceed accordingly, because if you have strings, you have to convert it into numbers for certain algorithm. So depending on that, you have to find out. So give info of will give you what are the data types that are supported. This is about the description. Okay, how many values are there? What is the count? Okay, so how many values are there? what is the mean, okay, of each and every column. What is the mean value? What is the standard deviation, minimum, maximum? And I told you this is for the box plot analysis. That is how many values lie between this 25%, 50, and then 70%. Okay. Now, this is a very simple command used to tell you what for each and every column, how many number of unique values are there. Okay. Suppose if it is global active power, if you take, how many number of unique values you have. And what are those values? If you want to visualize, you can do like so. This is combination, that's all. Okay. So print of column. What is the column? So it will go and it will print the column name. Global active power is the first column. Colon. So it will have it. I'm creating. This is actually in Python, we call it as dictionary. Dictionary, what will it have? It will have key value pairs, right? So column is the key. You can have any number of values over here. I'm going to have two values. How many number of unique values are there and what are the values? So this column is actually the global power now. Unique values is going to be how many number of unique values that particular column is having, 4186 value, and what are those values. So just we have printed. It's not going to add any value for your evaluation, just it's for visualization. So what are the columns? You can specify by using df.columns. Now that this is important, okay, correlation. So what are we going to do is, so in order to identify what algorithm you can use for the data set you have to go for first checking whether it is a supervised data set or an unsupervised data set. Now look into this data set, and here I have assumed global active power to be the output column and rest of all to be the input column. But it's not necessarily need to be. Okay, suppose if you feel like all the columns are just data and I don't have any distinction between input and output, you go for clustering algorithm. Otherwise, you go for supervised learning. Okay, I have assumed this to be a supervised data set, assuming this global active power to be the output and rest of all to be the input. Now, once fixed with the supervised algorithm, the next step is to find out whether to use supervised, that is regression or classification. Okay, so how to identify whether it is a regressive algorithm or a classification algorithm? Look into the different values, identify whether it is within a range or any specific discrete values does it have. That's why you can use this unique values. So 4186 unique values, which doesn't mean that you have discretization over there, and hence you can assume that to be a regressive operation. Okay, so what is regression? I want the value itself as the output. So once this regression is fixed, next is to identify what kind of relationship exists between your input value and the output. Is it linear or non-linear data set? That's where we end up with correlation. Okay, so correlation from 0 to 9, column 1 has values from 2 to 11. Suppose what is correlation? If there exists an increase in the first attribute, 0 to 1, 1 to 2, 2 to 3, here also you can see the increase, 2 to 3, 3 to 4, 4 to 5. Okay, the unit remains same. So how many ever units it increases here, the same it gets increased. So that is directly proportional and on the proper stipulated increase. So that's where we call perfect positive correlation. When there exists a disturbance in X, when there exists an increase in X, there will always be an increase in Y. Okay, at standard steps. That's what is perfect positive correlation. Now, on the other case, if you have an increase in one parameter and if it leads to a decrease in another parameter, we should go for indirectly proportional, which is negative correlation. Okay, so whether the steps in which you have an increase or a decrease remains constant or variable, depending on that you have perfect positive or normal positive correlation. So here you could see here I have given the correlation values here. Okay, so the perfect correlation exists between 0 to 1. Okay, 0 means the first column and the second column. Okay, so that is perfect positive correlation exists. And if you look at this data, like 0 and 4, if you see. Okay, actually, when 1 increases 0 to 1, 1 to 2, here you could see a difference. See, 10 gets down to 4, then there is an increase. No correlation, and hence between 0 to 4 you should not have any correlation or a very minimal correlation. Yes, minus 0.36. Okay, so that is about your correlation observation. So that's the same we have given here. So it is very easy in terms of Python. df dot correlation will give you all the correlation values between the different columns that you have. Okay, so by looking at the numbers it will be pretty difficult, so we go for this heat map. Okay, heat map is just a method to visualize that correlation, that is color value distribution. So look at the here 1 represented by 1, and then the minimal value. What is the minimum value? It is minus 0.4, that is represented as the black value here. Okay, so you can see by you looking at this, we want positive correlation. Positive means near to 1. So those who are in the light color, okay, or near to that will be taken as the positive correlation. So any value that exists like that you can take, or else on the other side negative correlation. Negative correlation means either on the when one increases the other decreases. So both are okay. Normally in research, it's a standard convention that any value that lie between plus 0.8 to 1 or minus 0.8 to minus 1, we call it as perfect correlation, and it is linearly distributed. Okay, so that's how you can arrive at that. When it is not of that kind, when all the value gets deviated, you will definitely observe a deviation when you go for using linear modeling. There you have to choose for decision tree or SVM type of machine learning models. That's all. Then the first pre-processing step, once this correlation analysis is done, we go for checking the first pre-processing step. So I'm going to check whether there are any null values or missing values. Okay, so the is NA means it will check whether there is a null value or not. So how many null values are there is given by this aggregate operation. Okay, so these many null values are there. Why? Because in lot many places we have observed this question mark, and all that would have get converted to only that NaN values. Okay, so that is what is the meaning of that. 25,979 rows are there with null values. Because what does it mean? At that particular time period, data is not getting generated. Okay, so now I'm going to fill that values. How to fill? There are different strategies. Here we are going to fill the missing value with the mean of each and every column. That you can fix. You can fix it with one single value like 0, or the minimum value of the day column, or you can go for using median, or you can go for using sum. It depends on how you this itself is a research interest. Okay, you can vary and find out what kind of impact that it is giving you on the training. Here I have used df.mean, which is the first column global reactive power. If you active power, if you take the mean of that column will be taken, and that will be substituted in all the places where you have NaN in that particular column. So once done, if you again run this is null command, okay, you can see 0. If you start working without doing this, automatically the algorithm will throw you an error. Now the next thing is, see here, if you look at, there are 20 lakhs data, but if you look at the distribution here, yeah, I'll just show 10 rows. Just a minute. Ma'am, it's 11:30. Can I take some 10 minutes?
Yes, ma'am. No issues, ma'am.
Yeah. Yes, you can see here in 2006, okay, 12th December, that is December month, 16th date, there are multiple entries. Okay, so you have at 5:24 p.m. you have an entry. 5:25 p.m. you can see, either you can go for working exactly with this data, or if I want to work only on the basis of hour or day or month, okay, that is also possible. So what we did here is, I am just going to resample the data. Okay, so I have a data set. I'm going to resample based on hour. Okay, hourly. I'm going to take the entire hourly data. I don't want to go like 1724, 1725, 1726. Between between 5 to 6, what is the data I do have? I'm going to take it as a single entry. So that's what I did here. Resample based on hour. Okay, so if you change it to month, okay, so I'll change it to month and show you. You can see the output here for first hour. So 17, 18, 19 will only be there. Okay, suppose if I change it to month, okay, you will get on monthly basis. See, only December, January, February. Likewise, if you change it to year, again it will be like so. Okay, depends on how you want the resampling to happen. Okay, so how do you do resampling? Okay, so I'm going to take the mean. You may take sum, you may take a median, you may take standard deviation, whatever you want, you can do the corresponding operation. Once resampled, this is what we did. The first pre-processing is your linearity checking using correlation. Second is you have to go for missing value analysis. Third is you have to go for normalization. By normalization, you could see here the first attribute, we have values from 1 to 10, like so, assume. Second, we have 0 to 1. Third, we have around 200 and something, 200 to 300. Okay, the distribution are different. If you want to visualize, everything will go on a different scale. And since the algorithms is also going to consider it as number, okay, the impact of this, see, this 240 will be considered as a very massive value rather than 1, which in really not in case. So what we do, all the values needs to be changed into a normal standardized value which range between 0 to 1. That's what is normalization. This feature range you can set. So normally it will be between 0 to 1, but you can have between, let's say if you want to have between 10 to 11 also, you can have. So once done, you will have all values aligned within the same range. So it's beneficial for both understanding as well as the weightage that will be given by the algorithm. See, look at here. All the values got rearranged to between 0 to 1. Any kind of normalization like min max or Z normalization, anything you can use, that's not a problem. It won't affect too much on the modeling. Now, what we did next is this global target power. Okay, this is what is going to be the output. Rest of all is going to be the input, but this lies on the first column. I'm going to move this towards the last. But this is actually programming style. But if you want to take out only this values, that also is there. But anyway, now the task is to divide your data set into two parts. One having your inputs, another having your output. That's what I did here. So X, I'm going to have from the first column till the sixth column. So once I change all these things, okay, you can see once if I change all these things, automatically our target value goes there. Yeah, which is the output value, because we have resampled like that. Okay, now I'm going to divide the entire data set, active power 1, 2, 3, 4, 5, 6, 7, 7 columns. No, I'm going to change it like this. So I'm going to have the first 6 columns as the input and the 7th column as the output. You know, the indexing will start with 0. And hence I'm going to stop with 6. So this is the 6th column, which is actually the 7th column indexed with 6. Okay, so if you run this, you could see. I'll first run this alone. Yeah, I'll print x dot shape. So how many columns you can see here is 6 columns. Okay, so and if you look at the small y, which is going to be the output, you have 47 entries. Okay, so that is the meaning of why 47. It was 20 lakhs something. Okay, why it has got to 47? Because I have resampled everything based on month. Okay, if I rechange it to R as usual, Okay, I have to execute the same again. Just a minute. I'll show you the data difference. Yes. Info, describe and all not required. Straight away will come for, yes, correlation. Then missing value analysis. Yeah, now we will resample according to our, okay, so 17, 18. Now you can see how many values you have. Earlier it was only 47. Yeah, now you can see it is 34,588. It depends since we have shrinked the data based on hour or month or year accordingly. Okay, now comes the training and testing. Okay, you have a data set. Now the same data set is what is going to be used by the machine for both training as well as testing. So there are different strategies on which you can use this. So one way is to use the entire data set for training and then to test the entire data set with the predicted values. That is one style. Okay, but generally what people say is 80-20 modeling. So 80% of the entire data set you can take it for training and 20% you can use it for testing. Okay, so which actually we cannot do it with the human being. That is, you cannot really segregate. That's where we have a modeling called, we have a package called train test split. Okay, what it does is it will randomly pick up 80% of the rows for training and it will randomly pick up 20% of the rows for testing. Okay, it will go in random so that you don't need to bother about the biasing. Okay, so bias in the sense I don't want to take the first 10 days data for training, the 11th and 12th data for testing. Rather, it should be combined and to have a mix of people. Okay, that is taken care of by this train test bit. What we did here, so I will need to have X training and X testing. These inputs needs to be divided into two portions for training and testing. Similarly, the output has to be divided into training and testing. Now this to this function I am giving input output. Here test size is 0.3, meaning that I am using 30% for testing, remaining 70% for training. Okay, but it's up to you. You can use 20 also and you can segregate. Okay, so now if I execute, you can see here, so 34,588, right? So 80% of that becomes 27,000 something. So if you want to print everything, so if you add up 27,670 and 6,918, you will get the total set. Now this is the only portion where we are doing machine learning modeling. Okay, it's very simple. It will get done one. That too, one is import statement, two are print statement. Only these two statements will execute your ML modeling. What I did is linear, from the linear model package, I'm creating an object called linear regression. Okay, I'm going to fit a line between X training and then the Y training. Okay, so what is X train? It is the input of the training data. Y train is the output of the training data. Okay, since it has multiple inputs and a single output, we call it as multilinear regression. Single input, single output, we say it is linear regression. Multiple inputs, single output, we call it as multilinear regression. And hence the equation line will become y is equal to m1x1 plus m2x2 plus m3x3 and so on plus c. So how many ever attributes it has, it will just go. Okay, so I have printed all the coefficients. See, the coefficient of the first attribute is 79.62. Second attribute, so what does it really mean? It is nothing but the impact or the weightage of that particular attribute which is contributing towards your output. How much? So which, looking at this, which is the most preferred attribute which is relating to the output is the first column. Okay, so that's how you have to perceive. As and when your weightage gets reduced, this won't have too much of impact on your output. And what about this intercept? Intercept is nothing but the global impact that is there on the data set. Okay, let's say if all the students have got only 90 marks in my subject, I want to boost +5 to all of them. What will happen? +5 is going to be the bias on the entire data set. Okay, that's what we call it as intercept. Generally, when we draw any graph, okay, so the line which crosses x is equal to 0, the value or the corresponding y value, we take it as intercept for basic understanding. Likewise, so 92.64 is the intercept or the value that exists as a bias in the entire data set. Okay, now we have fitted the line, okay, that can pass through most of the data points that are there. Now, how will you predict? How to test? Okay, that's where we have this prediction method. Only two methods. Dot fit is used to fit the model, that is to data test inputs. Okay, already I know what is the value which we have taken from the original case, which is y test. Now the model, machine learning model is going to predict. Okay, so I'm going to store it y predicted and I'm printing both the values. Okay, so I'll just execute. It will vary because I have changed. Yeah, now actually if you see here, the first value is 8.667, but what is predicted is 5.994. That is the error. The difference between these two becomes your error. Okay, so but the error is not there mostly here. Okay, it depends. Now, how to assess? What are the performance metrics you have in linear regression? Is the difference. See, the error is only the difference. You are expecting this point, but I can able to stand only in this point. What is the difference? The difference between this and this. You are expecting me to give 100%, but I can give you only 90%. So 100 minus 90, 10 is my deviation, right? 10 is the error. But what about the sign? Okay, suppose if I'm your expectation is 90, I'm securing 100. Okay, the error may be +10. Your expectation is 100, I'm securing 90, it is -10. But while going for error identification, sign is not a matter. 10 units I have deviated. Okay, that's where is the different error mechanisms. Mean absolute error. Okay, you divide, subtract, and then take the absolute value. Okay, so there is another strategy. So in order to come out of that sign problem, we square it. Square this automatically. Plus into plus will also be plus, minus into minus will also be plus. So it is mean squared error. Okay, but while you square, actually the magnitude will go increase. Okay, and in order to bring it down to the original pace, we go for root mean square error. Take the square root finally. That is root mean square error. Okay, so that's where you could see here mean squared value is 20.221. When you take square root, automatically it gets reduced, okay, into its corresponding value. So this is approximately okay because we don't have too much of error. So around 95 point something is the proper accuracy. So I didn't have done visualization, but you can use it pyplot or cplot for visualizing the outputs. Okay, so that's all I think I can show. There is another data set also I took. Just this coding also I took from Kaggle for representation. You can visualize like this. This is just for visualization. If you want, I can give the data. You can just go through. Okay. So many data sets I have come through while doing like this. Okay. I think I'm